Hello everyone and welcome back to the day 6 of our system design session. The use case is semantic layer generation using AI agent. So yesterday we discussed about the communication layer, how the each component should communicate with each other, what is the protocols where we have to use the synchronous and the asynchronous calls, and what are the different MCP, how we can use all this. So the next question is that how the complete workflow gets planned. So I will divide that into 4 categories. How the workflow gets planned means what is the job, how the planner agent decides its tasks. I will divide that into 4 parts. The first part is based on the that is deterministic. Okay, so if there will be some kind of if and else rules will be there. Deterministic means rules based. If this is present, then perform these actions. If else, if this, all these kinds of rule based. Okay, and that is very deterministic. And as per one of our architectural principles, we had learned that wherever some deterministic steps are possible, we have to adhere to that instead of considering LLM, because LLM is probabilistic, right? The second option is that state machine. Third is that state graph. Okay, what is the difference between these two? State machine means it will decide, given this task, what should be the next task. So, for example, given this task means this particular task is achieved by this agent, then what is the next task and which agent is going to perform that? And the third one is state graph. So what happens? We know that state graph, that is a schema for our land graph based workflow, agentic AI system, right? So there what we, in case of conversational AI, what generally we do, during the conversations with the user, the system retrieves the useful informations and then it prepares the state schema, that we can say that workflow schema. And there, for example, if I am planning, I am asking one travel planner to to plan my travel itinerary plan, to give me the itinerary plan. And then I will be giving that, okay, this is my destination place, and this is the date, this is the class where I want to, in which class of air flight I want to travel, and what are some other additional informations. So those get saved into the workflow as a state schema, and this particular workflow gets fed to the planner agent to decide what is the next activities, what is the next task, so that it plans, okay, for this task, if all these informations are there, then what is the next task, and then which agent is going to perform that. Generally for a travel plan, we have seen that, okay, I have given my destinations, date, air flight, and how many members we are going to travel, and what is the kind of other informations that we are going to do. So in that case, first thing is that, okay, it will check, okay, which are the cheapest budget, which are the air flights coming within the budget, and then it will check whether the accommodation facilities within budget and near to the airport or near to a specific location, any conference locations, all those it will plan. And then any kind of, there it needs some kind of taxi transportation, that also it checks what are the weather conditions, any shopping complex or shopping mall that is the tourist attracting place in that specific city. Then everything the respective agent, it calls, it plans the complete itinerary and it provides back. So that happens through the workflow state, like a conversational AI, right? The fourth one is LLM based. Okay, so first is deterministic, second is that state machine, third is that state graph, that is the through the workflow land graph, fourth is that LLM based. So directly, if we are having LLM, we should not jump directly into the LLM based. I have already told that as per the architectural principles, if something ambiguous, then in that case we have to use the LLM. So what we have to do, in the prompt we have to write that this is our goal and these are all the available agents are available with you, and you plan the complete itinerary for this specific plan. So that is the comes LLM. And the next one is that hybrid of this. So fifth one, when I say that hybrid, some scenarios, this is the best practice to be used in the production environment. So for example, in our semantic layer generations, you can say like that, you at first you tell me this will our semantic layer generations, we have already defined various agents, right? Semantic understanding, semantic reasoning, semantic validation, semantic evolutions. These are all auditory again next, and the response generation again next. So before semantic understanding, there are some deterministic steps also. So if you consider these are the 4 set which we have considered that ambiguous, and those should go as a steps in our agentic AI systems as a workflow, then you can say that what kind of things. Okay, if you are from the data engineering background, you should be having clear understanding that what each steps does. So if you clearly see like that, okay, when a new data set comes to your data lake or somewhere golden layer, wherever, whether that data processing, semantic reasoning, validation has already been present, the ontology is present. If ontology is not present, then give this message. If ontology is present, perform the understanding through the glossary generation and semantic understanding. Perform the reasoning if that is present. Then if reasoning, check the validations, cycle validations, everything reasoning is done. Else perform, if that is done, then else that performs validations, and then if that is already done, then perform the evolution. So you can see that this is a set of rules defined. If else, if else, if else. Then we have to follow that track instead of directly feeding to the LLM, okay, do this planner agent for this. In fact, the use of planner agent is a rule based in our use case. So this is the example what I gave you, how you have to find out what kind of planner. It is not mandatory that always the planner should have some kind of LLM. So this is a kind of framework, the 5 types of different scenarios I told you. And in order to pick some kind of use case, you have to think like that, okay, planner should go into which category, so that it will be easy to save LLM cost, to save you to get some ambiguity, inconsistent response, and also the response will be very deterministic. Okay. So now come to the second part of our conversation, that is memory. So what planner needs? Planner needs memory. Why? Because what are the successful, based upon the user query or the user scenarios, what are the successful use cases, successful scenarios it has achieved, that will be saved in the memory. It must have got some kind of human response, human feedback, human evaluations feedback. So all this will be saved into the memory, and those will be coming back in the similar kind of use case, similar kind of intent analysis when it comes. Those will be provided as a context to the planner, so that planner can plan the complete workflow effectively with the more accurate result, accuracy. So when I say memory, okay, so memory, again, what types of memory? I have categorized that into 5 major memories. One is that working memory. So each in a conversational AI, it comes as working memory. So that is like each turn the system and the user some interactions is happening. The next one is about the semantic memory. That means what is the reasoning is happening between the user query and the available resources. how that semantic relationship has been achieved, and that had supposed to give the better response. And the next is that episodic, how the user history, through the conversation with the user, how the history has been tracked for this specific users, what are the different roles, what is its preference, and what kind of questions he asks, what are his skills. All those will be coming under the episodic. And next is that procedural. So in order to answer a specific user query, what are the different workflow the system has followed. So that is like the procedural. That means it has some workflow, some tool extractions. What are the different steps it has followed? So that is coming on procedural. And meta memory is a kind of, it manages all these whole kinds of memories, and that is the meta memory. In our case, semantic layer generation, the memory, there is not any kind of conversations is happening. It's not happening. There is a one UI. We will design the UI in next session, might be in Friday. We will design its UI. So it's through the UI, the admin, whether the architect, whether the product manager, whoever they are trying to see. Okay, they are providing some information, and then the complete backend workflow is getting initiated, getting triggered. So in that case, it is the memory is like that for this specific metadata, for this specific data catalog. These are already the actions has been performed as part of the procedural. Semantic means definitely with the ontology knowledge graph, those semantic relationships will be coming and performing the response, right? So to the planner, memory is coming as an input. The next part is that how the search will happen here. So search, when I say that search, different kinds of searches, because our knowledge graph is now, that is ontology based, it has all the metadata, it has all the kinds of business rules, KPIs, what are the input, what are the different teams are there, team glossaries, business glossaries are there, all those informations are there. So when the user query, when a specific request comes to perform one kind of semantic layer reasoning, semantic understanding, to generate semantic layers for this specific data set, then it goes to search. Okay, what are the different informations are required for semantic understanding, for reasoning, validations. At first the semantic understanding, if I say, then it will be coming, the first one, what is the search, is that keyword based search. Okay, everyone knows. Then the semantic search, that is through the cosine similarity. And third one is the graph traversal. So it will pick up, the intent from the user request is getting picked up, and the corresponding node method, that node is again in the knowledge graph, node it depicts to the specific class or subclass in RDF, that is ontology RDF. And from there, that specific node is again connected with the other data, other properties through some edges relationship. So what is that? Some kind of object properties, some kind of data properties, some annotation, some business rules, those will be defined. So when the user request comes specific to that, then the user intent gets extracted and the corresponding node, and it is like all the edges relationship, then one small subgraph gets extracted, and that gets enriched with this keyword based search and semantic based search. So one subgraph through the graph traversal, okay, nodes to this nodes to that node, forward and backward. When this happens, then this gets served as the context to the planner agent to plan the specific task. So this is not specific to, it is not only to the planner, but instead of some other LLM also. If we explore that from text to SQL engine generation, there also this gets fed as a context, this subgraph. So then it gets that one. So from that subgraph, what will be the informations? What is the tenant? What is the user ID? What is the session ID? and all those information gets there. So again, there is a architectural concept that we need to discuss, how that should be separated as a multi-tenant graph. Okay, in a single graph instance, how that the multi-tenant isolation can be achieved. That is again one more question. One of my consultant had asked me about that one, so we will also design that. So these are the three concepts when we are talking about the planner. So what is planner? How we have to design the planner? What should be fed to the planner? The memories and the context should be fed to the planner, and then we are going to derive. So this is about today's session, and tomorrow we'll be coming up with a new topic. Stay tuned, and from the 12th of September we are going to start our session about this complete end-to-end to understand how in a single use case, how you have to decide what is the, how you have to do the market research, what kind of things should be done, what the problem statement analysis, and then come to the final, all these kinds of activities, functional requirements, non-functional requirements, derivations, all this. And non-functional requirement derivation is very much important also. So complete end-to-end, it is a training session, so we can say like that, that will span 32 to 35 hours, and that will be coming up as a part of the course itself. It's a paid course that I'll be sharing the course syllabus with you shortly. Thank you. Stay tuned for tomorrow's session.